Good morning. Everybody had a good week so far?
Eh.
Was it a or a yeah? Get our homework sheet, take a look. All righty, I think we've got everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You missing one?
Betsy and Sarah aren't here, I don't think.
Yeah, there they are. They're in. Let's see.
I'm right here. Evelyn.
Let's see who we're missing. I was thinking we got Kinsley, Evelyn. There she is. She's coming in. Now we got everybody. All right. Okay, so let's go ahead and get started. So hopefully you got your test uploaded. I did make a spot for that, didn't I? It just dawned on me. Okay, I started thinking I did make that assignment in there. So so if you make sure if you haven't gotten it uploaded, make sure that is priority 1 as soon as we finish or whatever. So make sure those tests are uploaded.
But my area of like house, the internet has gone down several times. So every time the internet is back up, I will try to upload it as much as possible. But
Okay.
That it couldn't retrieve the data, or it just couldn't go on the website anymore. So.
Okay, so if you have trouble and you can't get it uploaded today, just take a picture of it and email it to me. Okay, you can either take a picture of it and either email it or text it to me, one or the other, if you can't get it to upload today.
Yes, ma'am.
All righty, so we had our test assigned, and then our homework we had from the 24th was page 18, activities 3, 4, and 5. So let's go ahead and take a look at those. So let me get page 18. Went along with lesson 8. All righty. So solving roots was activities 3. So I will go down the left-hand column and then the right-hand column to check these. If you need me to repeat something, let me know. If you want me to work something out, let me know. The first one, the square root of 25 equals 5. The cubed root of 64 equals 4. The square root of 8 equals 2 times the square root of 2. The cubed root of 54 equals 3 times the cubed root of 2. 2 times the square root of 7 plus 5 times the square root of 7 equals 7 times the square root of 7. 2 times the square root of 13 plus 6 times the square root of 13 equals 8 times the square root of 13. And then 4 times the cubed root of 21 plus 9 times the cubed root of 21 equals 13 times the cubed root of 21. Any questions on the left-hand column?
What was 3 over the 3 square root of 54?
Okay, the way we read that is the cubed root of 54. So instead of saying the square root, if it's a 3, we call it the cubed root. So the cubed root of 54 simplifies. If you were to break it into prime factorization, you would have 2 times 3 times 3 times 3. So you'd be able to pull out a group of 3s. So you'd have the whole number 3. And then under the radical, you'd have the cubed root of 2. That 2 didn't have any buddies to go with it. So it would be the 3 times the cubed root of 2. Okay, right-hand column. right-hand column, I have 14 times the square root of 11 minus 8 times the square root of 11. I'll go ahead and pull this up. Equals 6 times the square root of 11. 17 times the cubed root of 14 minus 6 times the cubed root of 14 is 11 times the cubed root of 14. The square root of 15 times the square root of 3 equals, you would end up with the square root of 45, but then you would have to simplify that, and prime factorization would be 3 times 3 times 5, so you'd pull out your group of 3's as a whole number, and the 5 is left under the radical, so you would have 3 times the square root of 5. 3 times the square root of 7 times 4 times the square root of 5. You would multiply 3 times 4, which is 12. Then you put 7 and 5 under the same radical, so you'd have the square root of 35. That cannot be simplified because 7 and 5 are both prime. So your answer would be 12 times the square root of 35. The square root of 72 divided by the square root of 6 would end up being the square root of 12, but you would need to simplify that, and prime factorization would be 2 times 2 times 3. Your 2's would buddy up and come out as a whole number 2, and the radical of 3 would be left, so you'd have 2 times the square root of 3. 15 times the cubed root of 44 divided by 5 times the cubed root of 11. You would divide 15 by 5 and get 3. And then the cubed root of 44 divided by the cubed root of 11 is going to be 4. So your answer would be 3 times the cubed root of 4. And then 8 divided by the square root of 8 would end up being the square root of 8, which you would simplify into 2 times 2 times 2. So your simplified answer would be 2 times the square root of 2. Any questions on those? Any of those you would like me to work? All right, on section 4, greatest common factor, we had sets of 3 numbers here. So we had to find prime factorization for each of our 3 numbers and find what was the greatest factor they all had in common. So 16, 18, and 20, my greatest common factor is 2. 16, 20, and 24, my greatest common factor is 4. 10, 18, and 30, my greatest common factor is 2. Any questions on those? All right, activities 5, find the least common multiple of our sets of numbers. So again, here I had to start out with my prime factorization, but once I've done prime factorization, I then have to look and see what is the largest exponent for each of my factors to be able to figure out what my least common multiple is, okay? So here, 12, 15, and 16. When I do my prime factors, I find that 12, my prime factorization will be 2 squared times 3. 15, I have 3 times 5. And 16, I have 2 to the 4th. So I can see that for each of these, I have a 3, a 5, and a 2. So, but my largest exponent of 2 is going to be 2 to the 4th. So I'm going to multiply 2 to the 4th times 5 times 3. And my least common multiple should be 240. Any questions on that? All right, then we had 6, 8, and 9. Prime factorization of 6 would be 2 times 3. 8 is going to be 2 cubed. 9 is 3 squared. So I have factors of 2 and 3. My largest exponent of 2 is 2 cubed. My largest exponent of 3 is 3 squared. So I have to multiply 2 cubed, which is 8, 3 squared is 9, and 8 times 9 is 72. So your least common multiple is 72. Questions on those? And then finally, 9, 12, and 20. 9 is going to be 3 squared. 12 is 2 squared times 3. 20 is 2 squared times 5. So I have 2, 3, and 5. My largest exponent of 2 is 2 squared. My largest exponent of 3 is 3 squared, and then my largest exponent of 5 is just 5. So I multiply 2 squared times 3 squared times 5 and get 180. Any questions on those? All righty, good deal. So on Tuesday, we started looking at lesson 9. we started looking at translating our terms, translating our words into mathematical expressions. Okay, so I want to go ahead and start here today with reviewing this. And we talked about how we have to pay attention to our order and figure out, okay, when they give us an expression, what is the thing that is coming first? And then what operation is happening, okay? So let's go ahead and start with activities 2 on page 19. Excuse me. Okay, so it says the total of a number and 63. So the first thing I want to do is underline total, okay? The total of a number and 63. What word or what operation am I going to be looking at when I hear total? Look at your list of addition, subtraction, multiplication, and division terms. I can see that the word total is listed as addition. So that tells me I'm going to be using addition here. It says a number. I don't know what my number is. And remember, we said we would just let that be the variable x. And 63. We know that number. So, since it says number and 63, I'm going to write my x first. That is my variable, plus 63. Obviously, I can't solve this because I don't know what it equals to. I'm just writing the expression. So I'm just having to decode my words, put it into mathematical expression, but I'm not trying to solve this. Okay? Let's look at the next one. 17 fewer than a number. Okay, so let's look back at our terms. Fewer than is going to indicate which operation? Subtraction. Okay, so I know that I'm going to be subtracting, and I've got 17 and my number x. I always want to write number as n, but you can use any variable you want to. It does not matter. You could use x or n. It doesn't matter. Now what I've got to think about is, since addition is commutative, really my order doesn't matter. But with subtraction, it does matter. So I have to figure out which comes first. So 17 fewer than a number tells me that my number comes first. And then I have to take away 17. So if you see fewer than, I know I'm going to have to flip-flop my terms here. Okay? Fewer than means I'm flip-flopping my terms. Now let's look at the next one. A number times 11. All right. Number, I know I'm going to let that be x. Times, we know that we're going to be multiplying. This is where it gets confusing using x and times, okay? And then 11. So remember that when I'm writing a number and a variable together, I don't even have to have a sign, but I'm going to write my coefficient first. So I just have 11x, tells me a number times x. The next one is the sum. Hopefully you know immediately that that's going to be addition of 37 and a number. So we're going to be adding 37 plus x. If any of these confuse you or you have questions, please be sure to stop me. Okay, here's a word we may not be very familiar with, quotient. The quotient of a number and 10. Look at your list. Quotient indicates division. If you do not know some of these terms, take time to study them, okay? So I know I'm going to be setting up a division problem. Again, multiplication and addition are commutative. So if I really don't get my order exactly right, it's okay. But division and subtraction do matter. So we've got to make sure that, that we put them in order. So when I think of quotient of a number and 10, what I'm going to do is my number is going to come first. When it says the quotient of, whatever they tell me first in the order is what it's going to be. And I could either have x divided by 10, Or I could write it as a fraction and have x over 10. Both of those would be correct. I could set it up with the division sign, or I could set it up as a fraction. Any questions on that? All right, 8 less than a number. So think about that for a minute. Less than, I know as I'm subtracting, what needs to come first? My number or 8? My number has to come first. So it's going to be x minus 8. Now, a number increased by a factor of. Okay, now a lot of times when we think about increased by, I think, hey, addition. But if it's increased by a factor of, that is indicating multiplication. So I know that I'm going to have a number times 5. So I would just write that as 5x. I'm just writing them side by side. I understand that if there is no symbol between them, it is multiplication. 71, more than a number. Now on this one, like I said, addition's commutative, so I could have 71 plus n, but the way that it's written is that I've got my number first, and then I'm adding 71. So more than, flip it. So like when we see that word than, I know that I'm flipping to put my second thing first. Okay, so like fewer than, I need my number first. Less than, my number came first. More than, my number came first. Now this one says a number less than 104. So I'm subtracting, so I know that my order is important. So again, a number less than. That than tells me I need my 104 to come first, and then subtract my number. That than tells me I've got to flip them. The product of 19 and a number. So again, multiplying 19n. So product is one of those words that if you don't know that that goes along with multiplication, study that one. All right, ratio. Hopefully everybody now kind of has a picture in their head. Every time you hear the word ratio, you're thinking fraction. When you hear fraction, we are dealing with division. Okay, so ratio is division. So the ratio of a number to 2. Again, when I'm talking about, I'm going to come down here with this one. There's a couple of ways we could write this. We could write this as x to 8. We could write it with a colon in between, or we could write it as x over 8. You could write it either way, with a colon, or you could do it as a fraction. And then a number increased by 44. So that means I have my number first, and then I add 44. Any questions on how to know what words translate to as far as the operation? Any questions on how to know what comes first? Does everybody feel okay with that? Okay. So what we will do is our first part of homework that we will assign is activities 3 and 4. Okay, so that'll be on page 20, activities 3 and 4. I'm gonna go ahead and write that on my little note if I can find it. Let's see, I put it right here. So this is for activities or for lesson 9. Today is 8/27 is the date assigned. We have page 20, activities 3 and 4.
Again, I've already done that.
Fantastic. You are ahead. Okay, let's go ahead and look at lesson 10, the distributive property. Okay, so it says the distributive property allows another method of working with parenthetical expressions. All that means is we've got something in parentheses that are multiplied by a single factor. Okay, says in some cases it is easier to multiply each term in the parentheses by the factor outside the parentheses and then simplify. Now what we're going to be seeing here is like if I'm working with 2 times 15 plus 13, if I were to add 15 and 13, that's going to be 28, and then I would multiply 2 times 28. So I could either perform, using the order of operations, I could either perform what's in my parentheses and then multiply, or I can use the distributive property to multiply 2 times 15 and then 2 times 13 and then add them together. So 2 times 15 is 30, 2 times 13 is 26, and you add together to make 56. Depending on what your numbers are, sometimes it's easier to distribute than add. Like this one, 15 and 13, probably not too hard to do. Oh, that's 28. 28 times 2 is 56. But when we get into some bigger numbers, it might be a little more challenging.
So
now here's something, huh? I'm sorry?
Either way.
You can do it either way. You're going to get the same answer, okay? The place that this is going to come in handy the most is when we start talking with variables. When we have variables and we have to distribute, then that'll be where it comes into play more. Right now, if I know what both of my numbers are inside parentheses, I can add, then multiply by the number outside parentheses, or I can distribute and then add. I can do either one, okay? All right, this is something to think about. 2 parentheses next to each other with no symbol between them means you're going to multiply. Okay, so it is understood that if I have parentheses and nothing between them, I am multiplying. And then again, the commutative property of multiplication says that you can change the order of the terms and still get the same product. So 2 times 3 equals 6 and 3 times 2 equals 6. Doesn't matter my order. Then over here, the associative property. We just talked about this. We talked about associative property of addition and the commutative property of addition. Same thing with associative and commutative with multiplication. Associative, remember, tells me grouping. Hopefully you remember that. Commutative deals with order. Associative deals with grouping. So notice here, I can put my 3 times 4 together and multiply that first and then multiply by 2. Or I could group 2 times 3 first and get 6 and then multiply by 4, but either way, I'm ending up with the same answer. And then the identity property of multiplication says you can multiply any number by 1 and you're always going to get that number. Okay, one thing I want to add here is the zero property. And the zero property says that any number times 0 equals 0. Okay, so the zero property just says that any number times 0 equals 0. So let's look at this classwork 1. I have 4 times 10 plus 9. So in this one, if I wanted to, I could add 10 plus 9 and get 19 and then multiply by 4. Well, I'm not really good with 19 times 4. That's not something I really know, but I know that 4 times 10 is 40, and I know that 4 times 9 is going to be 36 because I do know those factors, and 40 plus 36 is 76. So for that one, it's easier to distribute than add. Same thing with 5 times 12 plus 7. 12 plus 7, again, is 19. 5 times 19, I'm not real sure about. But 5 times 12 is 60, and 5 times 7 is 35. So then I can add those together, and I get 95. 20 minus 3 is 17. I don't know 9 times 17, but I know that 9 times 2 is 18. So 9 times 20 would be 180. And 9 times 3 is 27. Still not a real super easy one to do, but if I say 27 is close to 30, so 180 minus 30 would be 150, and then take away 3 more, so I'd be at 147. Or you could always just set it up where you have 180 minus 27. What did I do? Oh, 143, not 147, see? $153. What am I doing? See, it's a good thing I checked my math. But again, we're in algebra, so you can use a calculator as well. Okay. Questions on distributive property. The main thing is understanding that if I have a number outside of parentheses, it must be distributed to everything inside parentheses. And that will be something, like I said, that we'll really talk about a whole lot more when we start working with variables. That's where it's going to be super important. Okay. So let's go ahead and take a look. I want you to go ahead and work on activities 2 right now. Okay, you can use a calculator, you can use pen and pencil, however you want to do it. Let's go ahead and take a few minutes to work on activities 2. While y'all are doing that, I'm going to go get a package off my front porch. Hang on just a minute. All right, y'all good? Does anybody need more time? All right, so let's go ahead and take a look at these. Okay, so if I have 2 times 35 plus 7, if I distribute 2 times 35 is 70, 2 times 7 is 14, so that's going to give me 84. The next one, 4 times 9 is 36, 4 times 5 is 20, so you should end up with 56. 7 times 1 is 7. 7 times 40. I know that 7 times 4 is 28, so 7 times 40 will be 280, so that'll be 287. 7 times 30 will be 210, same thing. 7 times 3 is 21, so 7 times 30 is 210, plus 7 times 9 is 63, so I end up with 273. 8 times 20, 8 times 2 is 16, so 20 will be with a 0, plus 8 times 9 is 72. Then when I add 160 and 172, I'm going to end up with 232. And then I've got to distribute to each term inside the parentheses. So I know I'm distributing 3 times here. 4 times 25 is 100. 4 times 9 is 36. 4 times 15 is 60. So I'm going to add these together. So 100 plus 36 plus 60 is going to be 196. Any questions on those? The main thing to remember is that with distributive property, it doesn't matter how many terms are inside the parentheses. I have to distribute the number outside to every single term. Or you can add them and then multiply. But just know that when we get into things, like I said, with variables and stuff, and we're having to distribute, it doesn't matter how many terms I have inside the parentheses, I've got to multiply to each, okay? All right, and so then we will do activities 3 on here as homework. Okay, so we're going to go ahead and add that to our sheet. So this is under lesson 10. We have page 21, activities 3. Notice that we have been doing a lot of practice with radicals. That's because it's important for us to really get this foundation down now. This book uses a lot of radicals throughout. And so if we go ahead and get it solid at the beginning of the year, when we get into more complicated stuff, it's not going to be nearly as difficult. Also, in geometry, they just expect you to know how to simplify radicals. So that's why we're using this time to really get good practice in to make sure that we're good and solid with that. Go ahead and turn to page 22. 22, we'll be doing prime factorization. I want you to go ahead and do that. Activities 4, prime factorization, use exponents where appropriate. And then order of operations, activities 5. So these will all go along with with lesson 10. So we have page 22, activities 4 and 5. Again, these are some basic skills that we have already reviewed several times, but we need to keep working with them to make sure we're good and solid. Do you have a question?
Are we supposed to do that now or as homework?
No, that's going to be for homework. Okay, so we have so far for homework, we've got page 20, activities 3 and 4, page 21, activities 3, and page 22, activities 4 and 5. And at the end of class, we'll go through them again. Okay. All right. Moving on to lesson 11. We're just trucking right along today. Whoop, I need to get my new page out.
Hi, Miss Jennifer.
Yes.
I don't have my book yet, and I printed off all the pages that you sent, and that was up to lesson 10, so I don't have like any lessons after lesson 10.
Did I not email the additional lessons? I was thinking I had emailed them out. Let me check.
I don't have them either.
Okay, well, I was thinking that I had emailed them last week, but let me make sure. Let me check and see. English pre-algebra. I'm sorry, I thought I had emailed those. I may have emailed them to myself and forgot to forward them. So let me do that real quick. Let's see. Go to my inbox. Okay, so Algebra 1. Okay, so who all needs this?
I do.
Sadie? There's Sadie. Who else?
I do, Miss Jennifer.
Mark? Does anybody else need them? Okay, so they are on their way. Sorry about that. I thought I had sent them out, but evidently I did not. I knew I had made the copies and got them ready. I'll send them to my Notability. All right, so as these are coming up, I'll go ahead and tell y'all that next week, obviously, our plan is to return to the classroom. And so I'm excited about that. I don't know exactly what the guidelines will be. I know that on Monday, the mask order will still be in place. It's supposed to expire on the 31st, but I would assume that it's probably going to get extended. My guess on that is just because with everything kind of opening back up, and it seems to be that the numbers have dropped drastically by using masks and having that mask order in place. So my thing is if it helps, then let's stay safe and get to be in school. I don't know what the rules will be. I don't know if it'll be the kind of thing where if we can social distance, when you sit down, you can take it off, or if you'll have to wear it. I really don't know those answers just yet. Also with the size of our class, it depends on how far we can space out. I think we've talked about, I can't remember if it was this class we talked about or if it's a different one. They said that face shields are acceptable. So anyway, shields, masks, whatever. But like I said, I know that Mr. Perry will be sending out more details about that on how the return to school will look. And I think there's even, I think there's a parent Zoom maybe tomorrow night, Friday night at 7. I want to say, so that'll be a great place to get information on what return to the classroom looks like for next week. With that being said, because we will be rotating and being in class one week and out of class the next, I want to try to have as much consistency as possible. I want to make sure that as far as lesson delivery goes, I'm still planning on delivering the lessons like we've been doing via Zoom. So I have actually what I've ordered, and it won't be here Monday, but I've ordered a projector. So my plan is to have my projector hooked to my computer where it will project the pages on the screen in the classroom. I'll still be working on my iPad and doing things, and it'll be kind of the same format. And then that way, if there are students who are not able to come to the co-op, you're still logging in via Zoom. If you find out that you've been exposed and you've got a quarantine and you've got to be at home, I want you to be able to have the same access as you've got to everybody in the classroom. Or, you know, everybody's got different health situations, family situations, whatever. So for some reason or another, there may be some people that are joining us in classroom and not joining us in classroom, but I want everything to be consistent. So my plan will be kind of the same delivery method. Now Monday it will be different because I won't have my projector just yet. So we'll work through that. But then for next Thursday, we'll be all set up. I'll have everything projected on the screen. I'll be doing everything on Notability. Our Zoom logins will stay exactly the same. So if you're at home on Monday and you're logging in, you're going to log in via Zoom. We're just going to be, the camera shot where I am will be in the classroom. Okay. And so, so anyway, also homework uploads are going to remain the same. I don't want it to get confusing of, was I supposed to upload this, or do I bring it to class, or what? I want all homework to continue to be uploaded just like we've been doing. Okay. So that will be across the board, no matter if we're in class, out of class. Upload your homework to the website. That way it remains consistent. There's no confusion. It's easier for me pulling the papers to grade, and then I can just email them back to you, and it's not a shuffling of papers. And, oh, I thought I gave you that paper. No, I don't have your paper. Where's that paper? Did it get mixed in? You know, all of that. From a paper management standpoint, it has helped me tremendously, especially those days like when you guys are uploading 4 pages for an assignment times 14 students in the class. That's a whole bunch of papers. So it's easier for me not to have those papers and just have it electronically. So that seems to be working. So just know that that will be kind of how we continue things. Okay. With that being said, the requirement is still that they are uploaded before class starts. Now, I understand that there may be, when we get back into class, things are going to be a little bit different. You may go, oh, I forgot to upload my homework. If that is the case, then at the beginning of class, I'm going to try to remember to ask, did everybody get their homework uploaded? And if you didn't get it uploaded and you've got a little camera app and you can take quick pictures and upload it real quick, that is just fine, okay? As long as you have a quick way to get it uploaded, that's going to be just fine. Again, I've been lenient as far as our timelines right now, kind of getting used to it all. I'll be lenient next week with us in the classroom, but then starting after next week, I'm going to be looking at those timeline deadlines, okay? And so that's why the timelines are set up for uploading the homework. And if something is uploaded late, it has it in bold red for me to be able to see that this did not get uploaded in time. And that's where you're going to start losing points, okay? So that's just on your effort grade. It is not on the accuracy. It's just the effort. Did you make the effort to, number 1, get all your work done, and 2, get it uploaded in time, okay? So we're going to keep working through that a little bit and getting used to it. And so at this point, you know, it's the kind of thing where if you have still any missing assignments, be sure to let me know. Real quick, I will ask, somebody texted me a whole string of assignments yesterday. Was that you, Sadie? Yes, I was thinking it was you. I always get confused when it comes in as a text through my email, but I know that we've done that a lot. And so I was thinking that was yours, Sadie. So I just wanted to make sure. I had it as yours, but I wanted to confirm. Okay. So, and if I did email you and you had any missing assignments and you needed to either get those uploaded, I'll be looking for those this afternoon, or if you needed to text pictures to me, make sure I've got those. Because like I said, starting week after next will be when I'm kind of cracking down on making sure everything's turned in on time. Any questions about that? All righty. So let's go ahead and move on to lesson 11. Okay. Sadie and Mark, just follow along on the screen, and then you can get your papers when you get a chance. One thing to mention, though, is when I've pulled this up, like where this says 1A from 912, that's been from a previous year, and I wrote in my book, and I didn't erase it before I took the copy, so don't worry about that. All right, so we've talked about evaluating algebraic expressions. And so it says to evaluate an algebraic expression, substitute the given numeric value for each variable in the expression. The same numeric value is used for every instance of the same variable. So if I'm looking down here and I have x equals -2, then everywhere I see x in my problem, I'm going to plug in -2. Now, sometimes we may see where it gives us variables for numerous, it gives us values for numerous variables, and we'll look at that in just a minute. So in this situation, And then it says to follow the order of operations to simplify. So the first thing I do is I'm going to rewrite my problem with my number plugged in, and then I'm going to use the order of operations to simplify. So you can see that here my number is -2. Notice that I've got 2x right here, and that's where I'm plugging in my number, my -2. I don't want to write 2 minus 2 like that. I want to make sure that since I'm multiplying, I want to make sure that I put that -2 in parentheses. Because especially number one, I need to know that I'm multiplying. Number two, I need to make sure that I've got that negative with the number that it needs to be with. Okay, so that's what they've done here is they've plugged in that -2, they put it in parentheses. So my recommendation is every place that you are plugging in a number for a variable, put that number in parentheses, okay? So we've put that -2 in parentheses here. We've kept the +6. So now 2 times -2 is -4. -4 plus 6 is +2. So we followed the order of operations by multiplying first and then adding. So your steps are going to be plug in your variable using parentheses, solve using order of operations. Okay, now it says when there are 2 or more unique variables, meaning that they are different, each variable will have its own value. So when you substitute, you want to make sure you have put the correct number in the correct location. So here, if x equals 2, then I know that right there I'm going to have to substitute x. If y equals -3, I'm plugging in -3 there. Okay? So let's go ahead and take a look here. Again, I'm plugging in 2, so they put that in parentheses. I'm plugging in -3 right here, so it is in parentheses. So now I'm going to use my order of operations on how to solve, okay? So I have 3 times 4 because 2 squared is 4. Then I have multiplication right here where I have a +2 times a -3. +2 times -3 is -6. Then I still have -4 left over in my problem. So I've been able to simplify a little bit. Now I need to keep going. So again, order of operations tells me I'm going to do 3 times 4 first and get 12. Then I have my -6 minus 4. I have subtraction in my problem, so I'm going from left to right. So 12 minus 6 is 6. 6 minus 4 is 2. Questions on any of that?
By the way, I think is it break time?
It is 11:12, and what time is our break time usually? 11:10, is that right? So yes, it is. So go ahead and take 5 minutes. Thank you for the reminder. Everybody ready to get started back? Let's see who all's back.
I'm here.
Very good. Jonas and Micah, y'all back? Good deal, Micah. Jonas? Jonas? Jonas, you with us? Is Jonas awake is the question.
Probably not.
Probably not. Oh, here he comes. I saw some movement. You with us, Jonas? Okay. All righty. So let's go ahead and get started back. We were talking about evaluating. So if you see the directions say to evaluate, that means you're plugging something in. A little bit ago, we were working with being able to write our expressions, but now we have them written out and we're going to evaluate them by plugging in the numbers that we did not know previously for variables. Once we know what our variable represents, or what we know what number is in the variable, then we can go ahead and solve for that. So let's go right over here to our classwork, and it says to evaluate each algebraic expression. Okay, so we talked about how when I rewrite my problem, I want to plug in my variable in parentheses. So I'm going to go ahead and write 4 times 3 plus 5. I went ahead and put my 3 in parentheses. This is especially helpful when I'm dealing with a negative. And then order of operations tells me I'm going to multiply, then add. So I'm going to have 12 plus 5, and that will equal 17. Okay. Now let's look at the next one. I have -5 times m. m is a -1. And I've put that in parentheses, plus 3. Order of operations, I need to multiply, then add. So -5 times -1. I'm thinking back to my rules that I should know about negatives now. So a negative times a negative is a positive, and 5 times 1 is 5, plus 3 equals 8. All right, the next one, 7y minus 2. I have my 7. I'll plug in 2 for y, and then I'm going to subtract 2. Order of operations tells me I will multiply, then subtract. So 7 times 2 is 14, minus 2 is 12. Now notice one of the things that they told us earlier, we'll flip back over here for just a minute, is that for each variable in the expression, if it's the same numeric value, if it's the same variable, you're plugging in the same number. So everywhere I see p in this problem, I'm going to plug in my -3 in parentheses. So I'm going to go ahead and write it underneath it just so I can make sure I've got it. So I've got 2 times my -3 goes in parentheses, my exponent's going to go on the outside, minus 3 times -3 plus 1. So each place I have p, I've plugged in my -3 in parentheses. Now, according to the order of operations, I know I'm going to have to deal with my exponents first. So I'm going to have 2 times -3 squared means I multiply -3 times -3. Negative times a negative is a positive, and 3 times 3 is 9. Minus 3 times -3 plus 1. All right, order of operations tells me I've got multiplication, I've got subtraction, I've got multiplication and addition. So I can go ahead and do my multiplication, both of them in the same step. So 2 times 9 is going to be 18. Then I'm going to keep my minus sign there. Since I have transferred my minus sign there, I'm only going to be multiplying 3 times -3. Okay, so I need to make sure that since I have moved this negative sign down, I'm not keeping that negative with my first -3. So now I've got +3 times -3 will give me a -9 plus 1. All right, so here I can see I have 18 minus a negative 9. I can change that to addition and add the opposite. So now I've been able to change those signs there. 18 plus 9 will give me 27, and 27 plus 1 is 28. Any questions on how we did that? As we're working through these things and working with our positives and negatives, it's real important that we make sure, like here, I could have used this negative with this, and I could have gone ahead and said -3, and -3 is a positive 9, and I would have just had positive 9 in the next step. I like to just go ahead and bring down whatever the sign there is, and then only use that, and then go from there, just so I make sure I don't combine things that shouldn't be combined. Okay, so I'm going to erase that so I can get to this problem right here. All right, now notice that we have x is equal to 4. So everywhere I have x, I'm going to plug in a 4. Y is -2. Actually, we'll do a different color for that. Y is -2. So when I have y, I put in my -2. Okay. So what I'll do is I'll have 3 times -2 times x times y plus 4 times y. Whoop, didn't want to do that. So I've gone ahead and set everything up with my parentheses. So now I'm going to plug in. I'll just do my different colors so you'll be able to see. So if x is 4, then that goes in that one and that one. Y is -2. So I've got to have -2 here and -2 here. Is everybody comfortable with how I plugged everything in? Alrighty, so now what we're going to do, order of operations tells me I'm going to be working from left to right with my multiplication. So I've got 3 times 4 here. I've got multiplication going on here, and I've got multiplication going on here. So 3 times 4 is 12. Again, I'm going to bring down that minus sign right there. So now that means I'm just multiplying these numbers here. So I have 2 times 4 is 8. 8 times -2 will be -16. I'm going to bring down my plus sign right here, and I'm going to multiply 4 times -2 will be -8. Now, addition and subtraction in order from left to right. I know that I have minus a negative, so that's going to be the same as plus a positive. So 12 plus 16 will be 28. 28 plus -8. I'm going to take my sign of my larger number. My larger one is a positive, and I find the difference of my two numbers. So 28 minus 8 is 20. Any questions on those? Alrighty, what I would like for you to do right now is let's go ahead and work on activities 2. I want you to work on plugging in those numbers for the variables and use the order of operations to solve. Okay, so go ahead and work on that right now. Is your mama teaching too, Zoe Owens?
Yes.
Okay,
Myself.
What do you do when a number is negative and has an exponent?
so you're going to put the negative number in parentheses, put your exponent on the outside. So remember that when you work that for the exponent, you're going to have that negative number times itself. So when it's a negative times a negative, it becomes a positive. But put your negative inside the parentheses, put the exponent on the outside. And what I'll do on these is I'll just go ahead and put the answers, and I want you to check your work and let me know if there's any of these that we need to go over. Well, actually, we'll just wait and go through them because we've got plenty of time. Okay, let's go ahead and start plugging in our values. So the first one, x is 4. So 3 times 4 plus 7. 3 times 4 is 12 plus 7 is 19. The next one, I'm plugging in -2 for p. So now, order of operations, I'm going multiplication then addition. I'm multiplying a -9 times -2. Negative times a negative is a positive, and 9 times 2 is 18. So 18 plus 8 is 26. Any of these that when I go over it, if you missed it or if you have a question about it, please stop me, okay? For the next one, I'm substituting -2 for b. So I have 3 times -2 will be -6. -6 minus 5. Okay, remember, if I have a negative and I'm subtracting more, that means I'm going to end up with a larger negative. Or if you would like to rewrite it as adding the opposite, you would have -6, whoops, that's a 5, -6 plus a -5. Whichever way helps you see it the best. So then that way you end up with -11. But just remember that if I start with a negative and I subtract, I'm going to end up with a larger negative. Okay, you can also picture the number line where you start at your negative number and then move left however many numbers, well, whatever way it, you know, for you to remember. All right, now the next one, I'm plugging in R. I have several places to plug it in, and it's a negative number. So -2 there, -2 there. Order of operations, I'm going to do my exponents first. So -2 squared would be -2 times -2. So that would be +4. -2 times -2 plus 3. All right, so I'm going to go ahead and I can multiply here and I can multiply here all in the same step. So 5 times 4 is 20. I'm bringing down this negative down here, so that means right now I'm only multiplying 2 times -2, which would be -4 plus 3. 20 minus a -4 is going to be the same as 20 plus a +4. I change to addition, take the opposite sign of the number afterward. So 20 plus 4 is 24 plus 3 equals 27. Any questions on those problems on the left-hand side? Any of them that you had trouble with? Any that you missed? How did you do with your positives and negatives? Were you able to keep them straight? Okay. All right, moving on to the next side. I am plugging in my variable. C is 3. So now I've got -9 times 3. Negative times a positive is a negative. I have opposite signs, so I have a negative answer. 9 times 3 is 27 plus 4. -27 plus 4, I have opposite signs. I take the sign of the larger and find the difference of my numbers. -23. On the next one, I'm plugging in 3 for K. So I've got -6 times 3. Negative times positive is a negative. 6 times 3 is 18. Plus 5. Different signs. Take the sign of the larger, find the difference. So -13. Plugging in 3 for T. Put my 3 there, my 3 there. Start with my exponents. 3 squared is going to be 9. So I have 3 times 9 minus 7 times 3 plus 4. Come out this way. All right, multiplication. I'm going to multiply here and here. 3 times 9 is 27. I'm keeping my minus sign, so now I'm just going to multiply 7 times 3 is 21 plus 4. I have subtraction and addition in the same problem, so I'm going to do them from left to right. 27 minus 21 is going to give me 6. So I have 6 plus 4 is 10. Any questions on that one? And then finally, we're plugging in both G and H. Okay, so G is -5. So I'm going to put a -5 here for G, a -5 here for G. And then I'm going to plug in H is 4. So I've got an H there and an H there. All right, so I've got some multiplication, subtraction, and addition. We're going to do our multiplication from left to right. I start with 8 times -5, a positive times a negative. I have opposite signs, so I'll have a negative solution. -40 minus. I've brought that down here, so now I'm only multiplying right here. 3 times -5 would be -15. And I still have times 4. Plus, now I can multiply these. 5 times 4 is 20. I still need to multiply these right here, so I have -40 minus -15 times 4. Negative times a positive is a negative, and 15 times 4 is 60. Plus 20. I have minus a negative, so I can change that to plus a positive because I want to add to addition, and I change my sign and then take the opposite of the one following. So now I have -40 plus 60 plus 20. So -40 plus 60 is going to give me 20, and 20 plus 20 equals 40. Any questions on any of those? Are you feeling comfortable about how to sub in the numbers? Are you feeling more comfortable with dealing with positives and negatives and using your order of operations? Okay. Let's go ahead and we'll do, I don't want to start another section. So what we'll do is we'll go ahead and work the left-hand side of each of these of 3 and 4, and then we'll have the right-hand side for homework, and then we'll finish up early today. But let's go ahead and review these together. Actually, I'll tell you what, let's do the right-hand side together because those look a little more challenging, and then you can do the left-hand side for homework. So let's go ahead and work on the left-hand side. We are on page 26. All right, so I have 2 times 5 cubed. Remember, this is the same situation where I can either say 2 cubed times 5 cubed, or I can do 2 times 5 is 10 and then have 10 cubed. Either way, I'm going to get the same answer. 2 cubed is 8. 5 cubed is, what's that? 5 times 5 is 25. 25 times 5 is 125. And so when I add, when I multiply 8 times 125, I get 300. Now let's talk about this guy right here. I have a negative exponent, okay? Negative exponents are one of those things that there's certain times where I say like bells and whistles and red flags, and you go, hey, I've got to think about what I know about this, okay? It's going to be something that looks unusual, but I know how to handle it. I've just got to think about what I've got to do to handle it.
Isn't 10 cubed 1,000?
Yes, why I just multiplied 10 times 3. Thank you. I'm not on my brain. Thank you, thank you. Whoop, all that went away. So I just started to write it again. All right, I think what I did is I wrote that exponent too big right there, and I put it in, make it little. There we go. Okay, so here we have our 15 to the negative second power. We know that our goal is to make that exponent positive. The way I make a negative exponent positive is by taking the reciprocal of the number. Remember, when I have a whole number, my understood denominator is 1. So this would be the same as 15 to the negative second power over 1. Okay, right now, that's exactly what it means. So what I'm going to do is to make that -2, my -2 exponent positive, I've got to flip it. So now my exponent has become positive, but it stayed with the 15 and it moved to the denominator. Okay. So now I've got to do 15 squared. I'm going to pull out my calculator for that one because I have not memorized that one. So I'm going to have to multiply 15 times 15, and that is 225. So notice it says solve exponents. You don't have to solve them greater than 3. This one is to the second power, so I do have to solve it. Any questions on how I did that? Remember, the goal is to make my exponent positive. The way I do that is to flip it. In a minute, I'm going to give you a couple of, actually, let's just go ahead and do that real quick. What if I had 1 over 13 to the negative third power? What if I had a negative exponent in my denominator? How would I make that exponent positive?
You just flip it?
I gotta flip it. Yeah, so I'd have 13 to the third over 1, which is the same as 13 to the third. So then I would just do 13 times 13 times 13. That would give me 2,197. Yeah, so if my negative exponent is in the denominator, then I'm just going to flip it to the numerator. If it's in my numerator, I flip it to the denominator. But flipping it, finding the reciprocal, makes my negative a positive. Okay? So whether it's in the denominator or the numerator, by flipping it, by taking the reciprocal, it's going to make it positive. All right, so here we've got 3/4 to the third power. So that means I have to distribute that 3, that exponent of 3 to both my numerator and my denominator. So 3 to the third, 3 times 3 times 3 is 27. 4 to the third, we've got 4 times 4 times 4, which will be 64. All right, now we've got to think about, I've got 27 over 64. Can that be simplified? I know 9 times 3 is 27, and 3 will not go into 64, and neither will 9, so that is my simplified answer, is 27 over 64. Okay, so in this situation, this will be 6 to the negative third over 5 to the negative third. So to be able to make those positives, I've got to flip them. So that makes it 5 to the third over 6 to the third. 5 to the third, we just found 5 times 5 is 25. 25 times 5 is 125. 6 times 6 is 36. 36 times 6 is 216. Again, on that one, I know my primes of 125 is going to be 5 times 5 times 5, and 5 will not go into 216. So there is my final answer. Okay, so the main thing to remember is if you have a negative exponent, no matter where the negative exponent is located, by flipping makes it positive. Then once it's positive, you can go ahead and simplify. All right, absolute values. Remember, absolute value is the distance from 0 on the number line. Therefore, if I have a negative inside my absolute value sign, it is still going to be positive because distance cannot be positive. So this becomes 51 plus 24. When I add those together, I get 75. Negative 26 becomes positive 26 minus negative 18. The absolute value is 18. And 26 minus 18 is 12. No, it's not. What am I doing? No. Sorry. 8. All right. We talked about how our absolute value can act as a symbol of grouping. So when we talk about PEMDAS, when we do parentheses, exponents, multiplication, division, addition, subtraction, when we talk about that first step P in PEMDAS, we call that parentheses, but it also means parentheses or other forms of grouping. That could be our absolute value signs. That could be brackets. It could be braces. You know, it can be all, whatever form of grouping. So in this situation, I am treating my absolute value signs as symbols of grouping. So I'm going to do 36 minus 47, okay? 36 minus 47 is going to give me a negative 11, but that is still in absolute value sign. So the absolute value of negative 11 is a positive 11. Minus 25 minus 18 is going to give me 7. So the absolute value of 7 is 7. So I have 11 minus 7, which is 4. Any questions on that? Then finally here, I've got a negative on the outside. The way I read this is the opposite of the absolute value of 52 minus 65. So the first thing I've got to do is I'm going to keep my negative sign there, and I'm going to simplify 52 minus 65. 52 minus 65 gives me a negative 13. I have my minus sign. Now I've got to solve 47 minus 59. 47 minus 59 is negative 12. I've got a whole bunch of negatives in here that I want to kind of clear up. I still keep my negative on the outside, but the absolute value of negative 13 is 13. Minus the absolute value of negative 12 is 12. On this one, I know that if I have negative 13 and I take away 12, I'm going to end up with a bigger negative, and 13 and 12 is 25. If I need to change it to negative 13 plus a negative 12, then if that helps you see it better, that is just fine. Change your signs. Okay? So that kind of gives us some more practice with our exponents and absolute values. So the homework on this page will be those left-hand columns. So you've already done the right hand. So just finish up the left hand. And so this goes along with lesson 11. So this is going to be page 26, activities 3 and 4. All right, so I have got, my time is 11:51. Like I said, I don't want to start a new lesson right now. We've covered 3 today, which is great. I don't want to pile too much on you. So let's go ahead and take a look at what the homework is. Then if you need to stick around and ask questions after we've gone over it, you're welcome to stay and ask questions and work on things. If you want to work on your work while I'm sitting here so you can ask questions, that's great. Stay logged in. If you're ready to go and you don't want to hang around, that's up to you as well, okay? But for our homework, let's do the homework rundown. Make sure you have this written down. For lesson 8, we're doing pages 18, activity 3, 4, and 5. Lesson 8, page 18, activities 3, 4, and 5. For lesson 9, we have page 20, activities 3 and 4. I'm sorry, I said lesson 8. That was from the 24th. My bad.
Miss Jennifer, didn't we have page 18 last time?
That's what I just said. I just realized that was from the 24th. So my bad. Scratch that off. Starting with lesson 9, page 20, activities 3 and 4. Lesson 9, page 20, activities 3 and 4. Lesson 10, page 21, activities 3. Page 22, activities 4 and 5. And then what we just wrote down, lesson 11, is page 26, activities 3 and 4. Any questions on any of that? All right, well, if you want to work on it right now where you've got me here to ask questions, feel free. If you have questions. I'm sorry?
What was the last one?
Page 26, activities 3 and 4.
Thank you.
We already did the right-hand column, so you just have to finish up the left hand. Okay? So if you're ready to go, you may go, and I will see you in class on Monday. If you want to hang around, hang around. All right? Good work today.
Bye, Miss Jennifer. Thanks for class.
You're welcome. Thanks, Mark. Let me know if you have any questions.
I'll email you if I do.
Okay, sounds good. Bye-bye.